Hey everybody, welcome back. In today's lesson, we are going to talk about estimating roots. This is going to build off of the last lesson that we did, which was square roots and cube roots. Usually when you do square roots and cube roots, everything that we have is a perfect square or a perfect cube. For example, these are like perfect squares, right? The square root of 25, the square root of 100, the cube root of 8, right? These are all perfect squares and perfect cubes because if you work these out, you have a perfect answer, right? There's no decimal on it. There's no fraction on it. Everyone should know most of these in their head, right? I think everyone knows the square root of 25. What number times itself equals 25? That's obviously 5. And here, 10 times 10 equals 100. Here's the cube root of 8. What number times itself 3 times equals 8? And if you watched our video the other day, that is definitely 2. 2 times 2 times 2 equals 8. So you see how these are perfect answers, right? No decimals, no fractions, perfect whole number answers. Now, that was the lesson yesterday. Today, they're going to start throwing in all these other numbers because does every single one of these questions always happen to work out perfectly like that? No. What if I happen to give you the square root of 12, right? Or the square root of 70, or the cube root of 15, right? These don't have perfect answers, right? And so that's what we're going to do today. We aren't expected to know every single one of these because actually look what this is. This calculator has a square root button. The square root of 12 is this. Are you supposed to know that? No. 3.464101615. And really, it keeps on going. My calculator just ran out of room. This is what we call an irrational number, a decimal that never stops, it never repeats. There's no way to write this as a fraction of two integers. This is irrational. All of these are. Look at the next one, the square root of 70. Boom. 8.366600026. Like, no. I don't know. That is miserable. The cube root of 15, this calculator actually has a cube root button. It's over here. I have to hit shift and then I can get to it. Look at that one, 2.466212074, right? Calculators on this can help you, but look what I have at the bottom. I see questions like this at a bunch of the map test questions at the end of the year. There's going to be like a 15-minute part of the map test at the end of the year where you do not get a calculator. And this is the type of stuff that they put on there. They'll ask you, hey guys, estimate this. Show me on a number line, what is the square root of 12 close to, right? They don't expect you to know the real answer. They just want you to say, what is this close to? Is it closer to 3 or 4 or 5 or 6 or 7 or whatever, right? And so that's what we're going to look at today. We have to estimate these. A lot of times they'll have you like drag a little thing and put a dot on a number line for them. And there is no calculator on these questions. Now that's okay. That is not a reason to panic. This is actually one of my favorite lessons of the whole year. Now, I talked about this a little bit in the Google Meet this morning, but if you didn't happen to make it there, if you don't get a calculator, you're going to need some type of reference to help you, right? And so what did I do? Imagine I'm an 8th grader. I'm getting ready to take this test. I know I don't get a calculator on it, but what I do get is a piece of scrap paper. And so what I would do is I would take my scrap paper, and before I even start doing the questions, I'm going to immediately take my scrap paper and I'm just going to make myself a little reference sheet or a cheat sheet. I don't want to call it a cheat sheet because it's not cheating. It's actually just a smart idea, right? One of my favorite students of all time did this. She immediately got her paper and just started writing down all the multiplying facts that she knew. 1 times 1, 2 times 2, 3 times 3, 4 times 4, right? We should all have these memorized. 7 times 7, 8 times 8. If you're in 8th grade and you don't have these memorized, oh man, I don't know what to tell you. Once it starts getting up here, okay, now maybe you don't have these memorized. 11 times 11, 12 times 12. Technically, we could get a question that went all the way up to 25 times 25. So I ran out of space. I only went to 15 times 15. But like if I didn't know the next one, like 16 times 16, if I don't know that, could I take 20 seconds and actually do the old school, like do this thing like you had to do in 5th grade, 6th grade, all throughout elementary school, trying to actually figure it up? And you could, right? And so I can see that 16 times 16 is 256. So it really is a smart idea to make a little cheat sheet for yourself here. It's not really a cheat sheet because it's not cheating. A reference sheet for yourself. And then you have all the answers that you need. I don't need a calculator. Since I don't get a calculator, I have this instead. And this is like my multiplication chart, and it's just as good as a calculator. In fact, it's better. Right? And then look over here in red, I did these. In the state of Missouri for the cube ones, 1 times 1 times 1, 2 times 2 times 2, where you're multiplying it times itself 3 times, you only need to go up to 10. The state of Missouri has said they won't ever get you higher than 10 times 10 times 10 on those types of questions. So you can see here, I didn't have 8 times 8 times 8 memorized. I don't expect you guys to have it memorized, but look what I did. I know 8 times 8 is 64. I think a lot of you all know that as well. But look what I did. I'll zoom in. I did 64 times 8, and I worked it out real fast, and then I put that as my answer, right? I don't know 9 times 9 times 9 in my head, and I'm the teacher of the class. So I'm not expecting you to memorize these, but what you could do is do 9 times 9. Everyone should know that's 81. And then here, really tiny, I did 81 times 9, and then worked it out. And so it might take you an extra 10 minutes, but you know what? That is okay. There's no time limit on the map test, so you can take as long as you want. If you want to take 10 minutes, make yourself a little reference page here. This will help you immensely on all of these questions, right? This calculator is not going to be available, so I don't even have that as an option. I'm going to need something else, and this is going to be my goal. So hopefully you all would be able to create one of those on your own. I'm going to use it to help me on all these questions here. I'm going to leave it just right there off the camera. And here's what the real questions may look like. They'll say, estimate this to the nearest integer. Integer is just like a number on the number line, right? 3, 4, 5, 6, 7. No decimals, no fractions. It could be negative, but most of these are not negative. Could be 0. Most of these are not 0. It's usually just a regular number, okay? Look at the first one, the square root of 35. Okay, I think I know some things that are kind of close to the square root of 35, but let me look at my chart just to help. Okay, this yellow marker's been working well for me today. The square root of 35 is really close here, right? 35 is in this range. It's bigger than 25, but it's less than 36. You see how I did that? Okay, 35, this is too big, too big, too big. 35 is right in here. It's in between 25 and 36. So I know my answer is going to be in between 5 and 6. When I do my number line, I guess I need to make this one go to 6. I know my dot is going to be in between 5 and 6. Now, do I just get to put it wherever I want in here? No. Do I put it right on the 5 or right on the 6? No, because it's not 25 and it's not 36. It's not exactly. It's not a perfect square. These are our perfect squares going down the black row there. This is 35. So just see, is it closer to this or is it closer to this? And obviously this one's pretty easy to tell. But if you need to, just count. How far away is 25 from 35? That's 10 places away, right? How far away is 35 from 36? It's only 1 spot away. So this is way closer to 6 times 6 than it is to 5 times 5. This thing should be way, like almost up against the 6 right here. Like it should be way over here. It's not on the 6, but it's really, really close to it. So you don't just put it in the middle. No. We're going to have to use our brains and say, okay, is it closer to here? Is it closer to here? Is it kind of in the middle? Right? And 35 is really, really close to 6 times 6, which is 36. One other thing you'll do, you might see this. Ms. Boseller talked about this in the Google Meet today. It's not an equal sign on these because we're estimating. We do like a wavy equal sign. That means approximately. So this was very, very close to 6. It was closer to 6 than it was to 5, and so the nearest integer was 6. Okay, let's look at the next one. The next one says 170. All right, I've got my little cheat sheet here. I'm going to just go, where do I find 170? 170 is bigger than 10 times 10. Okay, it's right in here, right? 12 times 12 is 144. Okay, 13 times 13 is 169. And this is 170, so it's just a little bit bigger. It's just one number bigger than 13 times 13, isn't it? 170 is bigger than 13 times 13, but just barely, right? This is way, way, way closer. It's only one number away. It's only 1 spot away from 13 times 13. It's like 26 numbers away from 14 times 14. So this is just a little bit bigger than 13, just the tiniest bit bigger than 13. I bet this isn't even like 13.1. I bet it's like 13.0 something. So this is going to be really close to 13. when I do my answer, wavy equal sign, this is very, very close to 13. And then if I had to do my number line, if they made me draw my own, I would maybe just do 12, 13, and 14. As long as the number that you need is in there, it doesn't really matter where you start. You don't have to start at 0. Some kids think, oh man, I got to start at 0 and go all the way to 14. No, 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 no. Just wherever you need to get. In this case, 13. I already forgot. Was this bigger than 13 or smaller than 13? Let me look. Okay, so 13 times 13 is 169. This is 170, so it's just a little bit bigger than 13. Like the tiniest bit bigger than 13. Look at that. I mean, just like right up against it, almost giving it a hug right there. Not socially distant from the 13 at all, right up next to it. Well, and that's how you do all of these. The next one says 44. The square root of 44. I'm going to erase this because it's kind of going to be in the similar area. So 44 is going to be, it's bigger than 6 times 6. It's less than 7 times 7. So 44 is right here, right? It's in between, oh wait, no, that's not right. It's bigger than 36. I'm going to say, I don't want to put it in between 25 and 36. How about in here? 44 is bigger than 6 times 6, but it's smaller than 7 times 7. Now, which one is it closer to? That's a little bit tougher, isn't it? So you got to use your brain a little bit. How far away is 44 from 36? And you can count on your fingers if you need to. 37, 38, 39, 40, 41, 42, 43, 44. It's 8. It's 8 spots away from 36. How far away is 44 from 49? 45, 46, 47, 48, 49. It's only 5 places away from 7 times 7, which is 49. So this is closer to 7 times 7 than it is to 6 times 6. See how I did that? I just took my number, and then I just counted. How close is it to this? How close is it to that? If you get the same exact number, then you know it's right in the middle. But this was not right in the middle. This is in between 6 and 7. So on my number line on this one, it's definitely going to be in between 6 and 7. But it's closer. It's only 5 spots away from 7 times 7. It's 8 spots away from 6 times 6. So it's a little bit closer to 7 because it was only 5 spots away. It's a little bit closer to 7. It's not right up against it though, but it's maybe, you know, like 3/4 of the way. And so it's not right up against it, but it is closer. It's approximately 7. That's the closest integer. Okay, the last one on here is the square root of 11. 11 is going to be way small. If I look at my list here, 1 times 1, 2 times 2, 3 times 3, 11 it would be right here, right? How close is it to 9? It's only 2 places away from 9. How close is it to 16? 4 times 4? It's 5 places away from 16. So this is closer to 3 times 3. And so if I did this one, this is going to be bigger than 3 because 3 times 3 is 9, but it's just going to be in between 3 and 4, but it's going to be bigger than the 3. Okay? So that's how you'll do these. Square roots. Make a little cheat sheet for yourself, reference sheet, and then just use that to help you. It works for cube roots as well. I'm going to just a couple of those and then I'll stop. I don't want this video to be too long, but I do want you to get some practice doing these red problems, the cube roots, where you have a number times itself 3 times, right? So here's the first one, the cube root of 62. So I'm going to look at my chart. 1 times 1 times 1 is 8. 2 times 2 times 2, I'm sorry. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. I'm going to go all the way. My number here is 62. So look how close that is. 62 is almost, it's almost the number 4, isn't it? 62 is really close to 4 times 4 times 4. It's a little bit less than 4 times 4 times 4, but it's really close. It's farther away from that. It's like what, 35 spots away from this, but it's only 2 spots away from 4 times 4 times 4. So this is really close to 4. I mean, this thing is like almost up to the 4. It's not quite there, but it is very close. I'm going to go ahead and just put some on here. So this is like the cube root of 62. Very close to 4 times 4 times 4. All right. The next one, cube root of 25, same idea. 25, it's bigger than 1 times 1 times 1. It's bigger than this. Oh, it's smaller than this. So 25 is like in between 2 and 3. Which one is it closer to? Just use your brain, common sense, right? 25 is really close to this, right? It's only 2 places away. It's like, what is that, like 17? It's like 17 places away from that. So this is way closer to this one. It's way closer to 3 times 3 times 3. It's only 2 numbers away from that. So it's a little bit smaller than 3 times 3 times 3, but it is closer to 3 times 3 times 3. So this is closer to 3. It's a little bit less than, right? Because 3 times 3 times 3 is 27, and this is 25. So it's smaller than 3, but it's going to be like right here. That's a 25. Sorry, it doesn't look very good. Okay, if the book tries to be mean, they might give you a decimal. Look at this one. Don't let the decimal bother you. It's kind of rude, but it's not going to hurt your brain. 129.6. So look at my chart. 129.6. It's bigger than this. Whoops, sorry. Bigger than 1, bigger than 27, bigger than... It's just a little bit bigger than this, isn't it? 129.6. It's just a little bit bigger than 5 times 5. It's very close to 5 times 5. It's kind of far away from 6 times 6. So it's in between 5 and 6, but it's very, very close to 5. So I'm going to put this one very, very close to 5. It's going to be maybe somewhere like just a little bit bigger than 5, right about there. Cube root of 129.6. Ran out of space, but that's what that says. And then the last one, I made it about as big of a number as they would ever ask you, 989. So all the way at the bottom of my chart down here, 989. We're going down, we're going down, we're going down, we're going down, we're going down. All the way down here. 989. It's bigger, it's in between 9 times 9 and 10 times 10. But which one is it closer to? Is 989 closer to this, or is it closer to that? And it's pretty obvious it's closer to this one, isn't it? It's only like 11 numbers away from this. And up there, it's like 270 numbers away. So this is definitely closer to 10 times 10. It's a little bit smaller than 10 times 10, but it is definitely closer to 10 times 10. So this one is closest to 10. I'll make a new number line since I was out of space. And that one didn't go all the way up to 10 anyway. So this is not quite all the way up to 10. It's smaller than 10, but it's pretty close to the 10, right? So 989 cube root is very close to 10, just a little bit smaller. Okay, guys, that's going to wrap it up. I don't know how long this video is. I bet it's about 15 minutes right now. I'm going to put some questions on the on the McGraw-Hill website. Remember, use this type of a chart to help you. In fact, let me kind of clean mine up a little bit. If you want to just like pause the video on this, right? I wish I can get the whole thing on there. I'll try to just get as much of it as I can. If you just want to pause the video and leave this right there, that'll help you with almost all of these. If I raise it up just a smidge, I might be able to get more numbers on there. So use this as like your notes, as your guide to help you. If you want to create your own, like on your own piece of paper at your house, and just basically put this in your folder or put it in your math materials so you have it with you, that might be a good idea, because these questions will be no calculator allowed. But look, were they really the hardest thing ever? They weren't that bad. Okay, guys, feel free to email me or Ms. Boseller if you have questions on the lesson. I will post it on Google Classroom in just a minute as soon as I upload this video. Thank you so much for watching, guys. Hope you have a good one out there.